This is Becca, often going by either Nightcat or Nightcat's Meow online, and welcome to the first video in my series on how to program in Linden Scripting Language. This is the coding language that controls the behavior of objects in the virtual world of Second Life. You know, the world you're looking at on my screen here. Now, some of you may wonder why you should be interested in a language that only works inside this specific virtual world. Well, LSL does have a structure that is similar to more prominent languages, such as C++, C#, Java, Visual Basic. In my personal experience, learning LSL first made it a lot easier to study those other languages. I got all the newbie mistakes and got the hang of all the basics out of the way in Linden Scripting Language before I tried to tackle the more complicated primary programming languages. Further, LSL is a great language to start teaching yourself to code because the initial projects are small, quick, they create obvious results and uses, and I find that tends to inspire more practice, more willingness to dig in and really learn to code. The next question some of you may be asking yourselves is, what is the difference between a programming language and a scripting language? Some people tell you it's a lot. I find not really. The hardest parts of coding are learning the thought process, how to go from the result you want and break it down into a series of steps a computer can follow. You'll learn that in a scripting language just as quickly and just as well as you would in a full programming language. But the main difference between the two is that a programming language creates the full program, obviously, such as anything that you'd be running on your computer, your laptop, your smartphone. Whereas a script, that language it runs inside the main program. So, for example, a game would be written with a programming language, but the behavior of a character, of an object, or a special ability inside that game would likely be written with a script. I also mentioned that the structure of Linden Scripting Language is very similar to those in common object-oriented programming languages, but since they run inside Second Life, some of the more complicated facets of programming, like memory management, these are handled by the parent program. As I said, this makes LSL an easier language to start with, and it'll be much simpler to expand your skills later instead of having to worry about all of it from the start. So with that said, let's start with our first script. This will be to make an object appear or disappear on command. For those who already play in Second Life, this is the very function that manages most weapon draws, most animated typers, and even some object transformations. We're also going to discuss the structure of a script, how each of the segments and functions interact, as well as how to trigger and control the invisibility toggle. So, without further ado, let's start creating a script. To do that, you have to have an object for the script to go inside. So a simple right-click, create, a basic box, hello box. Then you can look over here, the Content tab, New Script. There's your fresh little baby script. Pop that open, and you see several segments. Default is an entire block of code. This is a state. That number is what channel you're talking on. If you've been in SL for a while, you sometimes you will have encountered objects where you have to type slash a number and then it will do it, and a command, and it will do whatever whatever that command tells it to do. Those numbers are channels. You can set this to give a say on different channels, but right now that's not a thing we're going to worry about. We're going to worry about that a bit later, but not yet. So, the first thing we're going to do is we're going to prepare this to be able to turn invisible, and also visible again. So, it's going to have two modes. You could call it two states, but as we've already discussed, a state has a special meaning when it comes to programming. So instead, we're going to create a variable. In this case, it will be called a global variable. It's called global because it will apply to the entire script. No matter where in the script it is, this variable will matter. In other lessons, we will talk about local variables that only affect a certain section of the code, but that's not something we have to worry about right now. So we're going to go up here above the default state. Global variables are above a state. So first thing to create a variable, you have to tell the code what type of variable it is. In this case, we're using an integer. Integer is programmer speak for a number. 0, 1, 15. A basic, simple number is an integer. Don't try to put a whole bunch of decimals in there. That's a float. It's complicated. Just don't worry about it. It's more related to memory allocation and other complex stuff that you don't have to worry about with Linden Scripting Language, but you will have to know how to use them. So, in this case, we're doing an integer. That integer is going to be visible. That second entry is the name of the variable. So we have the variable's type, an integer, the variable's name, visible, an equal sign telling us what the value of visible is. Now, I did tell you that an integer is a number. However, there's a simplified way to deal with them in here if you're dealing with a simple toggle, which is a switch that can turn from one thing to another, which is what we're doing. We're going to tell it that it is true. This is a stand-in for a number, but it's a simplified way to do it. It's a way that is easier for us, the human, to understand what the computer is dealing with. It's a simpler way for us. It is for our benefit. Now, we're going to come here. We can take out the state entry since we don't need it for this. And we're going to create our first if statement. If visible equals true. Now you may notice that I just put two equal signs there. The reason is because when you're working with programming, you can do a lot of interesting variations. You can do is greater than or equal to. You can do an exclamation point equal sign, meaning is not equal to, meaning it is anything but that. So if you want the program to know absolutely that you mean exactly that it is equal to exactly that, you put two equal signs. Now we're going to extend it with these brackets. These little brackets mean that this controls every bit of code contained in these brackets. The same way you have the touch start has an open bracket and a closed bracket. Your state has an open bracket and a closed bracket. So will your if statement. What this simply does is when you touch the object, it asks, is visible true? Since it was set up here as true, it should be unless you've changed it. So if visible equals true, that means it is something you can see. We'll make it visible equals false. And yes, these have to be capitalized. It's just the way the language is structured. Now, when you're defining a variable or changing it, you can use a single equal sign. You're not comparing it to anything. You're simply saying, this is this. Visible is false. That's your first step. The next step you're going to have is LL set alpha. Set alpha controls the visibility of your object. Set alpha 0, all underscore sides. And that declaration is, of course, again, capitalized. Much like true and false are simplified for humans to say a given digit. You could actually insert the right digit in there, but it's far simpler to just use true and false. All sides is a shortcut that says every face of the cube. The cube in question, unless you've played around with cutting it up, has 6 sides to it. You could go through and identify each individual face that you wanted to make visible or not, and in a later tutorial we will do exactly that. But right now you just need to worry about all sides. Then, good programming practice is to put return at the end. Return is a way of telling the program to leave the set of operations you just created. So it goes in, it finds visible equals true. It will run this portion of code where it will change visible to false, set the alpha on the entire object to 0, and then return or leave. There are ways to use return to send information to another function, but we will worry about that in a future tutorial. Now the other part of this comparison is an else function. Because you only have 2 possible states, true or false, you can use just else. Later I will get into multiple sets of options. This will include something called else if. Don't mind that, I just kind of screwed up the placement of that briefly, but it's fixed. So in this case we're going to set visible back to true, set alpha, same thing we had up there, to 1. These go in a range from 0 to 1. So if you wanted it halfway, you'd have 0.5. Right now, we're just going on or off. All sides. Return. This is a simple toggle control. You have a global variable that will stay consistent no matter what else happens in the program. You have a touch start that activates or deactivates things, because if it's true, it will trigger this block, which sets visible to false, sets alpha to 0, and then returns or exits. If visible is not true, then the else comes in, which sets visible to true, sets alpha to 1 on the entire object, and returns out of the code. Once you have this in place, you can hit save. SL will make you wait a moment. Oh, we have a small problem. Error, name not defined within scope. That means the variable name here, it doesn't exist. The program doesn't know what it is. The reason is I spelled it differently here than I did up here. This error code was alerting us to that. Now these errors are really, really useful. Let's make it show that to us again. If you lose track of where it found your error, you can just go to any empty space, hit a space bar. The compiler will recognize that the code has changed and will allow you to save again. You'll wait a moment. It will come back with this again. Line 6, space 19, error, name not defined within scope, and it will place your cursor right along the area where the error is. So, I'm a crappy speller, forgive me if I'm replacing the wrong one, but change that. Now, these entries will be spelled the same way. And it has no error. Compile successful, save complete. We'll minimize this. Now we have the box. Invisible, visible. Each time I click it, invisible, visible, invisible, visible. That's how you control that. That is literally how every one of these in the entire grid works. Now there's a few wrinkles to this that I'm going to teach you before we close this tutorial. The set alpha command that I used there only works for this object, the object the script is sitting in. If I'm going to link these, come on, there we go. Now they're part of the same object. They're two different pieces of one object. Still, only that one piece changes. Now, since this is the root, if I click anywhere in the object, it runs the script in the root. Let's break those apart. And now I'm going to link that to this one. Now this is the root. Nothing happens. I click here, it still works. I click over here, nothing happens. If you want to restrict touch control to a specific part of the object, put the script only in that piece. If you put it in the root, you click anywhere on the object, and it will trigger. You put it in anything that's not the root, it will trigger only in there. There are other ways to determine where on the object it was clicked, and even what face of an object was clicked, but those are for a later tutorial. I want to build up to those skills piece by piece. So, what do you do to make the entire object go? Well, you make a slight change to your set alpha. Set link alpha. But because you're now setting it to affect an entire object, you have to add another argument. In this case, link underscore set. That is a shorthand that means the entire object. You can go through and affect only specific parts. You can specify a link number. And in a future tutorial, I will talk about getting the link numbers and using the link numbers and all of that. But right now, we're sticking with this. We're going to save this again. Compile successful, save complete. Minimize that. And now the entire object responds. Now, the next thing you're going to learn about turning things on and off is to do it with a different method. We're going to learn how to do it with a command instead of a click. To do that, you need a whole other operation. Touch start only works on touch. So we're going to add a listen. And that is a little more complicated. It involves two parts. First, we're going to bring back the state entry. You have to have this little place up here for arguments. Although state entry does not need them, you have to have it. So the first thing we're going to need is the listen command. LL listen. You have several arguments for listen. The first is the channel. We talked about that before. The default channel is 0. You're next going to need a argument for what is giving the command. This is a way that you can restrict it so certain objects can only affect it and then other things will be rejected. You don't have to worry about using that right now. You can just use a simple pair of quotation marks so that the code knows that argument is satisfied, but there's nothing there. It can ignore it, but it has to know what should be there, if anything. And you separate all of these arguments with commas. Every time you separate your argument with commas. And my apologies, dear viewers. I actually forgot to emphasize the most important point of coding. At the end of each line, there is a semicolon. Love your semicolons. Be devoted to your semicolons. Nothing gave me more of a headache when I was learning to code and when I first tried other languages before I got used to LSL. Nothing can cause you more of a headache than forgetting your semicolons. Always remember your semicolons. The only exception are containers like this that hold a whole chunk of code there. They do not have semicolons. Any line that issues a command that tells the code to do a thing has a semicolon. We have a semicolon up here where we establish the visible variable. We have one here where we change its state from true to false. We have one here for setting the link alpha. We have one here for return. Do not forget your semicolons. Back to listen. You have LL listen. All of these commands for Linden Scripting Language start with LL. You then have the bracket to contain its arguments. Your first argument is channel 0, separated with a comma. What it will be listening to, just 2 quotation marks, then a comma. Now you have a key. Some of you may already be familiar with keys, but they're basically like a virtual fingerprint. It is an identifying number for everything. Objects have keys. Textures have keys. Your avatars have keys. Everything has an identifying key. In this case, you could use that to restrict what can give a command to this script. But right now, we're going to keep this simple. Null underscore key. That will tell the code to ignore that. Then you have the actual thing it will listen for. If you leave that blank, it will listen for anything. We're going to leave that blank for now. Save completed. Now, the thing is, this only tells it to listen. It doesn't tell it how to do something with what it's listening for. For that, we need the second part of this. A listen handler here with the parentheses to take its arguments. Integer, chan. That corresponds to the channel it's listening to. And yes, you have to specify all of this out. It won't work otherwise. Integer, a number. Chan, you're defining the channel. Next, string. In programmer speak, a string is a set of text. Your name would be a string. Compile successful is a string. So, string, what? Because this would register the name of what was speaking to it. Comma. Key, we were just talking about that. Who, because this would be used to further identify who was sending it. It could be used to break down, like if you're using a HUD, it can identify that the message is coming from your HUD control, from your button that talks to it. And in a future tutorial, we will actually build a system that does that. And then another string, message. And since this is a container, no semicolon up there. Now, if, just like down in here, the if visible, this is going to be if message. If message exactly equals, that's the double equal sign. And since we're going to use a string of text, you have to put quotation marks in here. So, if message absolutely equals on, close the quotation marks, close the bracket, add your container brackets. We're going to pull this up here just for convenience. If message equals on, set link alpha, all sides, visible, Yes, I'm making typos. Never mind those. Whoops, almost screwed up there. Visible equals true. Again, the semicolon. And return. Then we're going to have another one. Else if message equals off. And we're going to run the same code as down in here. So just copy and paste that up there. And because we're actually controlling the visible variable, these will work side by side with your touch control. You can do either. You can do one or the other. You can do both. You can make them entirely independent. If you wanted to have the command control make no difference on what it remembered in terms of whether it's on or off, you could turn those off. It wouldn't know. It would continue. The touch would function independently. It would get awkward. I'll even show you how. And here we go. Completed. So we're going to go down here. Off. On. Off. And I click it, and it functions the same because it remembers. Now I told you one of the things that could get a little confusing, and this is where you have to learn to think through your programming, is if you have a command you can type that will turn it on and off, but it doesn't interact with the visible variable. Here's one more little trick for you. It's called commenting. You put 2 forward slashes in, and the entire line turns red. What this means is that the script will ignore that line. It will treat it as though that line is not there. This is a very convenient way for you to leave notes in the program. You can put that in there, and the compiler will ignore that entirely. So you can leave things in there reminding you about this variable does that. This function is for this purpose. To look to another section of code for something. You can put your notes in there, and the compiler will ignore them. Comments are purely for the benefit of the human, not the machine. Now, with this setup, where the touch control toggles its variable on true or false, but the command control does not, you'll see where that gets a little awkward compared to the real world. It's on right now, so we're going to tell it off. Now if I click it, the touch control just told it to turn off. This is a bit of a problem. I click it again, it comes on. This can be confusing because in the real world, if you're used to clicking it on and off, and then you have a way to command it on and off, you would expect it to know that it was off. But because we turned the visible variable off in the command control, it didn't know. This is an example of learning how to think through the code because, frankly, computers are fast, computers are precise, but they only do exactly what they are told, nothing more. They cannot take something and go, this makes sense, and follow along the way a human will. You have to tell it everything. It is a very fast, very precise moron. The last thing we will cover for this lesson is every time that we do compile successful, it restarts the entire script. This means visible gets set to true. I haven't saved it yet since turning those back on, so let us turn it off. Everything is set to on there. We're going to save. Now I click this and it will think it's turning itself off. As you see, nothing happened. Click it again and it's behaving normally again. This is because we turned it off, but when the script started, it registered that this variable should be true, despite the fact that its state in the world was off, which would be that being false. The way to avoid this is with state entry. The way we're going to do that, we're going to just copy and paste. Make that line up just so it's pretty. That to turn it on at the start of the script automatically. So we'll turn that off. We'll make the script reset. Just put a space in there anywhere so I can hit save. Close it. And it turns itself back on. This keeps it synchronized. Is this absolutely necessary? Not really. Is this picking nits? Kind of. But it's the kind of thing that if you want things to seem to just work, that you have to keep in mind. And there you have it. My first tutorial on Linden Scripting Language and your first steps into a wider world of programming. I should have another video up about a week from now, or depending on how far in the future you're seeing this, it may already be up. I hope to see you there. Enjoy and happy coding.